Hi everyone, welcome to the new session of Gyan. Today let us see Python data structures, especially which one? Stack versus queue. Let us see what is the difference between stack and queue. So before coming to the point, we must familiar with data structures and its classification. So it's divided into primitive and non-primitive, and we know that primitive means fundamental. So under this category, integer, float, string, boolean are the types are coming under this primitive, and under non-primitive, array, list, tuples, dictionary, set, and file. List is again classified into two, linear and non-linear. Under linear, stack and queue, two types of data structures are there. Non-linear, graphs and trees. So the built-in data structures, user-defined data structures are there. So list, tuple, dictionary, set, all this coming under built-in. Whereas stack, queue, tree, linked list, graph and hash map coming under user-defined data structure. So let us see what is stacks. We know that stack is a linear data structure and which follows a particular order for insertion and manipulation of data. So we can tell it as stack uses last in first out or LIFO phenomena to input the elements to the stack. So from the figure you can see that there are two main operations, push and pop. So we can keep the elements one top another like this. So the main two operations on stack is push and pop. You can see in the figure also empty stack. Then into the empty stack we can push elements and it will be keeping one top another, and the insertion can be done on the top. In the same way we can delete the element from the top itself. That is what is called pop. Okay. That's why stack is in LIFO structure. We are telling that stack is in LIFO structure. Now let us see Python stack implementation. So from this figure also it's very clear what is push and pop. Then stacks are very common data structure. We can see the stack main applications in compilers, the process passing data between delimiters, and in the case of operating system program stack, and in the case of virtual machine manipulating numbers. Okay, and in the case of artificial intelligence finding a path. These are all the application of stack. Then let us see what are the stack properties and attributes. Properties, we have already mentioned that stack are LIFO data structure. All access are done to the element referenced by top. The top always refers to the topmost element in the. So the insertions are done above the top elements. So let's see what are the attributes. We can see that size, the number of elements in a stack, size greater than or equal to 0 at all times. Otherwise it will be empty stack. Then top means topmost element of the stack refers to null, a special value indicating top doesn't reference anything in the stack. So the main applications of stacks are recursion, and some machines are also known as which use built-in stack hardware called stack machine, and representation of Polish notations. These are the additional applications of stack. Then let us see what is queue. What are the specialties of queue? So in this also we can add and remove the elements, but there is a little bit difference in adding and removing elements from the queue. So the main primary queue operations are Enqueue and Dequeue. Like checkout lines in a store, we are all familiar with queue and all. So front and rear will be there. Enqueue means insert an element at the rear, whereas dequeue means remove an element from the front of the queue. So insertion and removing, deletion is taking place in both ends, not like in stack. That is the difference, main difference between stack and queue. We are all familiar with queues in real life situation also. The same thing is happening here also. So stack is following LIFO structure, but here in the case of queue it's following FIFO in structure. So let us see what are the properties of queue. Queues are first in first out data structure, that means FIFO or LILO, last in last out. So add the items to the end of the queue, access and remove from front. Okay, used extensively this in operating system, queues of process, input output request, and much more. So let us see some of the application of queue. In real life examples, we are all familiar with queue, waiting in line, or if you are doing some process, we need to wait for our chance. If you're sending some request to taking the printout, if the printer is already taking the printout, that specific task will be put on hold mode. Likewise, these are all the applications, real life applications. Then what is the special application related to computer science? Let us see. So we are all familiar with the job scheduling methods like round robin, job scheduling, and keyboard buffer. These are all the main applications of queue in computer science. Hope the topic is very clear to you. If you like the video, don't forget to subscribe and hit on like button. Thank you.